Going to walk through solving a polynomial equation by factoring. First up is the zero product property, and that states that when you multiply two numbers together, if their product results in zero, it's implied that one of the factors, or maybe both of the factors, were actually zero. So if a times b equals zero, it's implied that either a is zero or b is zero, and that would be the base property that you would need to understand for the skill that you're getting ready to learn. Next thing is the vocabulary word, roots. Roots would just be another word for solutions, which are just simply variable values that make the equation true. Variable values that satisfy the equation. Graphically, roots are just simply x-intercepts, where the graph crosses the x-axis, and we'll need that skill or that term when we study the graph. The new thought that's probably going to be the hardest to understand at first is that the degree of the polynomial determines how many real number roots or solutions you can have. So theoretically, a polynomial of degree n has at most n real number roots. And to make that simpler, a quadratic, which is mainly what we're studying in Algebra 1, a quadratic is a degree 2 equation, or a degree 2 polynomial. So a quadratic, which is a degree 2, can have at most two roots, two real number roots or solutions. So the degree of the equation determines the number of real number roots or solutions that you can have. Up until this point, you've only studied linear, like something like 5x plus 10 equals 15. You've got a degree 1 equation, therefore you have one root or solution. We're now moving up to the degree 2 equation, which means that we can have two roots or solutions. So let's see how this looks in the midst of a problem, solving a problem in an equation. So first up, the first three, well, first of all, the mental checklist for solving a polynomial equation. Place the equation in standard form and set it equal to 0. Then completely factor, and then you set each individual factor equal to 0 and solve. And the solutions that come out of that serve as the roots or the solution set for that polynomial equation. So here I can see in number 1, it's already factored for me and it's set equal to 0. So I just simply need to take each individual binomial factor and set it equal to 0. So I can see that my first root or solution is -4. My second root or solution is -9. So my solution set would be -4, -9 in the braces. I just want to point this out on the first example. If I were to double distribute and turn this into a trinomial, it would look like x squared plus 13x plus 36. And it's an equation, so I will set it equal to 0. But the trait that I would like to point out right now is I've got a degree 2. So this is a degree 2 equation. I notice that I have two solutions or roots. So the degree of the equation determines the number of x values that you can have to satisfy the equation or to make it true. And since I've set the equation equal to 0, this is where the zero product property comes into play, because I'm looking for the x values that actually make this initial equation true. So let's do a few more on the video. Number 2, it's pre-factored for you. It's already set equal to 0, so I simply take each individual factor, set them equal to 0, to arrive at the two roots or solutions. So the first root is +4, the second root is -3, so my solution set would be 4, -3 in the braces. Looking at number 3, the difference of squares, the pattern. My first root or solution would, or my first root would be -5, and my second root is going to be +5, setting each individual factor equal to 0. The way that I would present this solution set, I would write the positive and negative sign on top of each other, and then the number 5 would follow, and then I would close my braces. That notation just implies that one root is +5, the other root is -5. Let's move down to the second row where the problems are not pre-factored for you. So a problem like number 4 is going to require that you understand what it means to rearrange it in standard form, and it's going to require that you know how to factor. So number 4, I'm going to add 24 to both sides, setting this equal to 0. It's now time to factor. factors of 24 that sum to negative 10, so it's going to be negative 6 and negative 4. Then you need to run through your factor by grouping skill. Introduce your parentheses now. The GCF in the first binomial is x, leaving x minus 6 behind. And I need to remove a negative 4 so that I have positive x plus 6 left behind. So my two factors are x minus 4 and x minus 6, meaning that my two roots, the first root is positive 4 and the second root is positive 6. So notice that I have a degree 2 quadratic and I have two roots or solutions. And to present those roots in their set notation, it would be 4, 6, and order really doesn't matter, but the ability to recognize the solution set and recognize what it implies, that's an important skill to take into this unit as well. So let's go on and finish up a few more of the problems in the notes before I end the video. So a problem like number 5, it's already, it's already set equal to 0. The constant would be 0, so I don't have to worry about a constant. I just have a quadratic term and a linear term. The greatest common factor is 3x, so when I factor that out, what remains behind is x minus 6, and then I take each individual factor, setting them equal to 0 to find my two roots or solutions. And I want to focus for just a minute on the monomial 3x. If 3x equals 0, then it's implied that x itself is 0. So my first root is actually 0, and then my second root is going to be positive 6. A problem like number 6, it's tempting to want to divide both sides by 2x, but the rules say set the equation equal to 0 first. So that means that I've got 2x cubed. I'm going to subtract 50x from both sides, setting this equal to 0. Then in my mental factoring checklist, I'm going to look for a greatest common factor, and that's going to be 2x. That's going to leave me with x squared minus 25. So the binomial that remains is actually the difference of squares pattern. So that means that my factors are going to be x plus 5 and x minus 5. So when I set each individual factor equal to 0, the root resulting from 2x equals 0 is 0. The root resulting from x plus 5 equals 0 is negative 5. And the root resulting from x minus 5 equals 0 is positive 5. So my three roots here are going to be 0 and positive negative 5. And the trait that I would like to point out is I started with a degree 3 equation. Notice I have 3 solutions. So I'm just trying to directly link that together for you. And before I stop the video, I would like to do problem number 7, because finding the roots requires solving a 2-step equation. So let's look at number 7 before I close the video. So number 7, it's already factored for you. It's already set equal to 0. So just simply take each root and set them equal to 0. So this is a 2-step equation. So I would add 3 to both sides, divide by 2. So my first root is 3 over 2. Here I would subtract 5 from both sides, divide by 3. So my roots are 3 over 2 and negative 5 over 3. And I think that's enough for the video.